So in 12.2, we were asked to create a data table of inputs and outputs for each function and to sketch the graph on the provided axes using the domain -5 to 5. So that's really just talking about the inputs -5 to 5. And then for each function, we need to state the coordinates or the equation of the following for each: the y-intercept, x-intercepts, the vertex, and the axis of symmetry. Then we need to complete the square to confirm that we have the correct vertex. And the problem I want to show you all of this for is problem number 6. So let's turn there. So I've got my graph here. Notice that the graph is giving me a certain range and domain, so I should probably have outputs that would fit into here at some point. And notice that I want to identify all of these different properties of the function. So let's first start with what we're given. This is standard form equation, so I know that my c term is going to represent my y-intercept. So right away I know my y-intercept is going to be, when my input is 0, my output will be -7. So that's already one point that I can plot down here of 0, -7. Doesn't have to be perfect. That looks like it's right there. And I'm actually going to label that point as 0, -7, so that I know that that represents my y-intercept. So first part down. Now I also need to identify the x-intercepts and the vertex. So let's actually identify the vertex next. Now there's a few different ways you can identify the vertex, and let's just outline that process quickly. You can identify the vertex first by converting the function into vertex form, which is a parentheses x minus h squared plus k, and then identifying h and k. If your equation is in standard form, then your vertex will be at the coordinates -b over 2a, and then the output when you input that function of -b over 2a. That's another way to calculate the vertex. A third way to calculate the vertex is to find k, which is the midpoint of your, not k, h, which is the input, is the midpoint of your x-intercepts. Okay, so really h you can think of as x1 plus x2 divided by 2, and then once you have that value, you can plug it into your function to get your k value. So really, I can show you all three ways in this one scenario. Let's actually just focus on the first two. The third one is a little bit more of a trick that is more useful for functions with clean x-intercepts, which this function will not have. So I'm actually going to choose to use method 2. And if I do that, then -b would be -9, since I've got a, b, and c here, over 2a, which is -3. So I've got -9 over -6, which is actually just 9 over 6, which reduces to 3/2. So that is my h value. Now I can find my k value by inputting my input of 3/2 into the function and evaluating. So every x will be replaced with a 3/2, and my y value will just be my output after I go through the order of operations. So this becomes -3 times 9 over 4 plus, this would be 27 over 2 minus 7. -3 times 9 is -27 over 4 plus 27 over 2 minus 7. We need a common denominator for all of these. And let's use -4 as our common denominator. So let's just double the second term to be 54 over 4, and then multiply -7 times 4 over 4, which would be -28 over 4. So this ends up becoming, let's see here, -27 and -28 combined to give us -56 over 4 plus 54 over 4, which gives us -2 over 4, which is -1/2. So my output, k, is -1/2. So right away, I know that my vertex is going to be at the coordinates 3 over 2, comma, -1/2. So in theory, if I take this a coefficient, I can actually get my vertex form equation by just substituting in the appropriate values for h, k, and a. Voila. And we'll actually double check that by completing the square to ensure that that's our vertex. So if my vertex is 3/2, comma, -1/2, let's actually graph what that point looks like here. 3/2 is just 1/2, and if it's -1/2 for our output, we're going to have a point right around there. And if this is my vertex, I can actually label that so and say that this would be at 3/2, comma, -1/2. And that'll be that point there. And since this is my vertex, I know that there's going to be an axis of symmetry that passes through it here. This axis of symmetry is helpful when you want to quickly graph a quadratic function without making a huge list of inputs and outputs, which I actually have asked you to do. But this would be useful to know because I know that on both sides of this line, I'm going to have the same inputs and outputs. So in theory, I should have an output at 3 that is equal to -7. And we'll actually test whether or not that's the case with an input-output table shortly. But right now, let's just label it as 3, comma, -7, and we'll see if that actually holds up. So according to this, I'm not ever going to cross the x-axis, even though I get really close to it. So because I never cross the x-axis, I know that I'm going to have no x-intercepts. How can I verify that I'm going to have no x-intercepts? Really, it's as simple as looking at the discriminant. And the discriminant, if we remember from our last unit, is b squared minus 4ac. So let's actually calculate what that is. This would be 9 squared minus 4 times a, which is -3, times c, which is -7. A lot of people messed up when they kept track of their signs in calculating the discriminant previously. Keep track of that. So I've got 9 squared, which is 81, and I've got negative times a negative times a negative. That is going to give me an overall negative. 12 times 7, which gives me 81 minus 84. So this is -3. So my discriminant is negative, so that means I have no real x-intercepts, which matches what I've got on my graph so far. Okay, so now that I have my vertex, I'm actually going to label that quickly as well. In my table, I've got 3/2, comma, -1/2. My axis of symmetry is just going to be this k value, this h value, which is x equals 3/2, because that is a vertical line, and that is the general equation of a vertical line. So now all we need to do is make sure that our vertex form equation is correct. Let's actually do that by completing the square, and I'm going to do that over here. So we've got -3x squared plus 9x minus 7. First step is going to be extracting -3 from these first two terms. So I've got -3 parentheses x squared minus 3x minus 7. Now I want to actually find C2. Now C2 is going to be calculated using b over 2 squared. And the b I'm going to use is this 3 here. So -3 over 2 squared becomes positive 9 over 4. And what I'm going to do with that 9 over 4 is I'm going to add it inside the parentheses and subtract it outside the parentheses. But the key thing that I have to do, and I mentioned this previously, is multiply by this original factor of -3 to my subtracted term outside the parentheses. That's going to be essential, so make sure that you don't forget about that. Now, this middle parentheses trinomial factors down into a perfect square. That's why we find C2 in the first place, and all you have to do is divide this b term in half, which we've already done, and that's x minus, 3 over 2 squared minus 7, and now I can, since I'm subtracting a negative, I can add 9 times 3, which is 27 over 4, and 7 becomes 28 over 4, so this becomes x minus 3 over 2 squared minus 28 over 4 plus 27 over 4, which is -3 parentheses x minus 3 over 2 squared minus 1/4. Does that match what we've got earlier? No, it doesn't, because we have a k value of 1/2. Let's see if Mr. Chacon was off in his math anywhere. So this is always a good way to double check your work. So 3 halves squared is 9/4. 9 times 3 is 27. 27 times 2 is 54. Negative 27 minus 28 is 56. Nope, that's not right. It's 55. So if this is negative 55 plus 54 over 4, we actually get negative 1 over 4. Now, if this was negative 1 over 4, does that match what we got? Boom, it does. So let's actually determine what we should write here. That would be y equals negative 3 parentheses x minus 3 over 2 squared minus 1 over 4. And voila. So to graph this quickly, all you need is those points. We don't have any x-intercepts, so really it's just a matter of curving this out in that way. Voila. And I mentioned that I want to test this point for my input of 3. So f of 3, and let's see if that determines negative 7. Well, f of 3 would be negative 3 parentheses 3 squared plus 9 times 3 minus 7. And this would give me negative 3 times 9 plus 27 minus 7. This would be negative 27 plus 27, which would cancel and give me negative 7. So that works, and we know that the axis of symmetry holds up. So again, this is an example of how you calculate the important points from a function given in standard form to quickly graph it, including the x, y intercepts, the vertex, the axis of symmetry. Now, one thing I do want to point out, if I were to ask, or if I was asked for the x-intercepts, all I would need to do is solve this equation like I normally would, either using factoring, the quadratic formula, or completing the square. Now, that's just going to depend on what the form is given to you.